In this video, we're going to talk a little bit about the different LlamaIndex index types, what they are, when you would use them, what use cases would you use one particular index type over another. These were questions that I had as I was working through this, so I thought I would make a video to share my findings. So there are 4 index types here. There's a list index, a vector store, tree index, and a keyword table index. And you can see in the documentation here there are some diagrams that visually show us what's going on, right? So with a list index, we're creating an index sequentially off a series of nodes, and a node here represents some information. Maybe it's a document or a piece of a document, and then when it comes time to query our index, the way the list index works is it goes through each node sequentially, unless we filter by maybe a keyword, or do an embedding based query, which will only fetch the most similar. Let's say we want to find 3 most similar nodes to our query. We can do that with the list index. Now that also happens to be how the vector store works, based off of embeddings. And so the vector store index is all about similarity search. So it's good for semantic search because it's, not the exact word, but hey, this might mean the same thing as this. So I've used vector store index for most of my use cases. It gets the job done in terms of, generative semantic search. Tree index, if you have some hierarchical set of data or information that you want to be able to index, this is where your tree index comes into play. And then keyword table index extracts keywords from each node, creates somewhat of a map, and then when you query now, based off of those keywords, that tells us what nodes we need to extract our data from. So made a little cheat sheet here, I guess you can call it. And the important part is okay, so when would I use a list index over a vector store, right? And for cases where you want to summarize something, a list index is going to be superior, because let's say you've got a super long document that you want to summarize. A vector store index isn't going to allow you to do that, because it's only going to, when you query, it's only going to fetch the most similar nodes to your query, right? So you can still query and say, hey, could you summarize, XYZ, but it's only going to fetch 3 documents that are similar to XYZ. Whereas the list index, if you say, hey, summarize this thing, it's going to go through all the nodes of that document, let's say, and go through each one, and then check the query and say, hey, do we need to refine our response based off of this query? Okay, let's move on to the next node, and so on and so forth until it has summarized the whole thing. Hopefully that's a decent example. Or let's say you need to store and retrieve like a chatbot history, and what's important there is it needs to be sequential. So a list index where you want to retrieve some kind of sequential data, that's ideal. Tree index is, like I said, hierarchical. So if you've got, let's say, a file system, right, and you want to navigate through some type of directory structure that has subdirectories or subsections, then a tree index is ideal. So, quick example off the top of my head, let's say you actually have like a directory where, it's broken down by departments, and then each department maybe it has some teams, and then each team has some employees, and you want to find what employee does what particular thing. In that case that I just made up, a tree index would be superior than a vector store or list. Keyword table index, I was wondering for a long time, why would I use a keyword table index when there's this, vector store index, which has the benefit of like semantic search. Why would I felt like keywords was moving backwards, right? But there are instances where you need to extract exact matches, right? So like specific words and terms and phrases. So the example here I have is a legal document search engine finding documents containing specific keywords. You might not want a vector store for that because it might give you results that aren't exactly relevant, right? Might have a similar meaning, but with the keyword table, we can get like exact, right? So, hopefully, you found this useful. There is a little bit of overlap, for example, with the list index in being able to embed your query and just fetch, top K similar nodes like the vector store. And then LlamaIndex also offers the ability to compose index types over another index type. So, for example, you can have you can compose a list index over a bunch of tree indexes, or you can compose a tree index over a bunch of list indexes. I'm just making that up, but it all comes down to the use case and exactly what type of queries you're expecting and what type of information you want to be able to retrieve using this.